Okay, we're going to look at exercise 15C, question 3H. Thanks to a class question, f of x equals minus 4x cubed plus 15x squared plus 18x plus 3. We want to know, when is the function increasing or decreasing? Right. So I have sketched it. I didn't need to do that. I've sketched it on Desmos. You could do it on your calculator. And I can see really easily where the function's decreasing or increasing. Now we're working from left to right. Okay, so we're always thinking of as x values are increasing, what's happening. So this whole region of the function here is decreasing, right? The y values are going down as we go from left to right until we get to x is minus 0.5. In fact, I can write the answer if it lets me. So I could say, no, I need to sort out my pen. It's not working. Right. So we're going downhill there. We could say f of x is decreasing, right, for x such that x is smaller than minus 0.5. So down here, x is smaller than 1, and the function is going downhill. It's decreasing, right? It means that it has a negative gradient. Right? And this is why it relates to derivatives, because if I worked out a gradient, so I work out the gradient here, from the derivative, it would be negative, right? And that would tell me that the function is decreasing. It's also decreasing here. Right? So that point there, x equals 3, so it's also decreasing when x is greater than or equal to 3, right? However, it's increasing from there, down there, to here, where x lies between, right? So f of x is increasing, right, for the set of x such that x lies between minus 0.5 and 3. Right, so in that region there, we're going uphill. The y values are increasing. Right? So there's the question done, right? No, not quite. We need to do it without the graph. We need to be able to do it algebraically, and we will do that now. So I hope. We'll have a crack at it and see what happens. So what you can do is you can find your slope function, and you can figure out where would you get negative results and where would you get positive results. Okay, like where do you have positive gradients, where do you have negative gradients? Because if you have negative gradients, then you're decreasing, you're going downhill. And if you have positive gradients, you're increasing, you're going uphill. Now, an easy way to find the spots where it changes, right, from, so you had this general shape, didn't it, my function, something like that, right? Here it's decreasing, right, so you could say gradient's negative there. Here the gradient's positive, right, so the derivative would have to give me a positive answer. And in here, the derivative has to give me a negative answer, equals some negative number, right? But at these points, there, the gradient's actually 0, right? So just for a minute, it's like it gets positive, 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 positive. Oh, it's less positive, it's less positive, it's 0. And now it's negative, right? So these are called stationary points, right? The function is considered to be stationary, right? Just at that point, it's not increasing and it's not decreasing, it's become stationary. And the gradient just for that instant equals 0, right? So I'm going to find where those zeros are, because they'll be the barriers. That'll be where it changes from negative gradients to positive gradients, right? So I could say my derivative equals 0 when, let's write when properly, when minus 12x squared plus 30x plus 18 equals 0. Let's divide everything by minus 6 to make this easier to work with. So we'd get 2x squared minus 5x minus 3 equals 0. Now I need to factorize. I can split the middle term. So I could say 2x squared minus 6x plus x minus 3 equals 0. Now if you're not comfortable with what I'm doing, you can go to your calculator to find the x values where it equals 0. Basically I've seen that 2 times 3 equals 6, and I can split this middle term using factors of 6. So that's all I'm doing. We've got 1 x minus 3, just so I can factorize by hand. So what do I get? X minus 3. But yeah, I mean, in a test you can use your calculator. Right? And now I can find solutions for x. So x has to equal a half from here. So if x is a half, then 2 times a half is 1. No, it has to equal minus a half. Minus a half. That's better. 2 times minus a half would be minus 1 plus 1, and then that will give me my 0. This is null factor law. Or x could equal 3. Right? Right, so what have I done? Just to be clear, I need to know, when does this bit equal 0? Well, it equals 0 when 2x equals minus 1. That's x equals minus 1 divided 2, or minus a half. Okay. The other one's easier to see. So how do you make this bit equal 0? 3 minus 3 equals 0. If that's 0, then the whole thing's 0. Null factor law, right? You can draw a little diagram at this point. We call it the sign diagram. Put on these x values. Minus a half. I need to label the diagram. I need to say this is a diagram of the derivative. Okay, it gets a name, the sign diagram, not, okay, this is not anything to do with trigonometry. It is not sine, as in the sine function. It's just a diagram of positives and negatives. Like, are we positive or are we negative? Right? So what I want to know is our derivative, right, is it positive or negative in this region? I know here, right, so right on there it's 0, and right on there it's 0, yeah? But I want to know in the regions either side. So in this region, in the middle, and in this region, are we positive or negative in our gradients, right? So if I took a number that was smaller than minus a half, maybe, I don't know, minus a million or something, and I plug it in here, I could figure out if we have a positive or a negative value. Now I think minus a million is not actually very clear. I'm going to do some tests. I'm going to test minus 1. X equals minus 1. Right, so I'm going to test in the derivative function. So it would be minus 12 times minus 1 squared is minus 12, minus 30, because I'd have minus 1 times 30, plus 18. Is that a positive or a negative value? I don't really care what the value is, but I can see it's negative, right? Because that'd be minus, that 18 is not enough to get it positive. It's minus 42 plus 18, whatever that is. It's some negative number, right? I'm going to test x equals 0. Why that? Why 0? Because 0 falls in here, and it's really easy to test with, right? So I'm looking at this region. If I make x equals 0, that's 0, that's 0, and I'm just left with 18. So it equals 18. But what I really want to know is it positive or is it negative? So that's positive. This one was negative. So, right. And out here, now this is maybe I can test positive 1,000,000 here, something really big. Will it help? The problem is with the minus 12 and the squared and I'm going to test 4. Right. Sometimes you can just test a really big number and it becomes obvious what's going on, but no. Why do I write a 2? I need a 4. I need something that's greater than 3 to test out in this region. Let's try 4. So our derivative would become minus 12 times 4 squared. Right, so that'll be minus 12 times 16, which is minus 128. Then we'd have plus 30 times 4. Let me just check that. 4 squared is 16. 16 times 12, because I should be getting negative. 16 times 12 is not 128. It's 192, isn't it? 16 times 12. Well, 8 12s are 96. 96 times 2, 192, and then there's a minus. Sorry, my bad. Plus 120, and then we also have the plus 18. I'm not going to work it out, I'm too tired, but I can see that it is negative, right? Because the 120 and the 18 are not enough to get this above 0, right? That'll be 138. That's minus 192. This thing's negative, okay? All right, so there's my sign diagram. I've tested it out. So if your derivative is some negative number, right, it means that your gradient is negative at that point. And what does a negative gradient mean? It means you're going downhill. You're downhill, like that. And it means that you're decreasing, right? And vice versa. So if your derivative is positive, your gradient is also positive. You're going uphill like this, and you are therefore increasing. Okay, so working, I think about these things visually. So that's why I'm drawing these pictures there and there. Working from left to right, the y values would be going down if our derivative is negative, giving us negative answers, and the y values will be going up, right, in a region where derivatives give positive values, okay? So, knowing that, we can therefore say that the function itself is decreasing where the x is smaller than minus 1 or greater than x equals 3. All right, so we've got x being smaller than minus a half. Is that what I said? Not even sure. Or the x is greater than 3. Right, and I'm not really worried about this set notation, to be honest. We could just say x smaller than minus a half, maybe comma, x greater than 3. Now, I think the book uses smaller than or equal to or greater than or equal to. I'm not really worried about that either. Technically, if we're exactly on minus a half, then the function is not increasing or decreasing because the derivative equals 0. We're at a stationary point. But I'm pretty sure your textbook uses these smaller than or equal to, greater than or equal to. The function is increasing when the x is between those values, between minus a half and 3. So we could say x lies between minus a half and 3. And if you want to use set notation, all you need to do is use curly brackets to say the set of x such that, and close your curly brackets. Right. Yeah, we'll leave it at that. So there's a couple of ways to express that. But that will do. Okay, thank you.